So these are our pre-calc notes for 6-2, matrix multiplication, inverses, and determinants. And this is going to be a two-part video. I'm not sure exactly when we're going to stop it yet, but it's going to be too long to do in just one video. So the first thing we need to do is figure out how to multiply matrices. So this is like the background information that we need for the rest of the notes to actually make sense. So with matrix multiplication, if we are finding AB, and A means matrix A times matrix B, and A has dimensions. Let's see, dimensions m by n, and B has n times p, or n by p. These two, so this would be our columns from A, would have to match our rows from B. So these must match. And you'll see when we're multiplying how that actually works out. And then the other two letters, this would be our rows and our columns, are going to be the dimensions of the answer. So again, let's remember when we talk about matrix dimensions that we are talking about rows by columns, which we remember because that's RC, like remote control. So we've got a nice little way to remember that. Basically, when we are multiplying matrices, we are multiplying a row by a column. We are multiplying rows by columns. So it's kind of an interesting pattern. So we're going to start out just by exploring matrix multiplication a little bit. So we're going to find AB, which means matrix A times matrix B, and then we're going to reverse it and do BA. So we're going to find the products. It says if possible here, because remember, if these don't match up, we can't actually find the answer. So I don't worry a lot about this and figuring out if they match or not, or what my answer is going to look like. I just start multiplying, and it's going to be pretty obvious right away if we can't actually do the multiplication. So I'm going to go ahead and slide this up. And I'm going to write out matrix A and matrix B. So matrix A is 4, 5, let's see, 1, 9, negative 6, negative 3. And then here's B. And the way this works is I am multiplying a row by a column. So I am going to multiply this row, and I'm going to multiply it by each of these 3 columns. And because I am using row 1, it's going to go in row 1 of my answer. So I'm going to have row 1, column 1 of my answer is going to be from right here. And then I'm going to have column 2, the middle part on my answer. And then I'm going to have that last column. And it's all going to be in the first row. So the way we do this is when I'm multiplying the row times the column, I'm going to multiply these first 2 elements. And then I'm going to have a plus sign. And then I'm going to multiply the second 2 elements. So that means 4 times 7 plus 5 times 2. So that's going to be like all one answer when I'm done with that. It's going to be one element. And then I'm going to multiply this row times my middle column. So 4 times 0 plus 5 times 6, and then times my last column. So again, we're multiplying the first number of each plus, and then we're multiplying the second number of each. And that's going to be my entire first row. It's going to be 3 elements in that first row when I'm done. So now I'm going to move to my second row. So now I'm going to multiply that second row, the 1, 9. Is going to get multiplied by all the columns as well. And so it's going to go in the second row of my answer. So I'm going to have 1 times 7 plus 9 times 2. And you know what? I really should leave a little bit more space to work them out. So let's just leave ourselves a little bit of space. I could do them right here in the box with this kind of, or, I mean, there's different ways to show the work on this, but I just find that kind of writing out all my little individual problems together and leaving plenty of space and just working it out right here is the easiest. I'll show you what I mean here in a second. Plus 9 times 8. And then I also have to work out my last row times each of these columns. So that's going to be in row 3 here because I'm using row 3. So negative 6 times 7 plus negative 3 times 2, negative 6 times 0 plus negative 3 times 6. Negative 6 times 1 plus negative 3 times 8. And there's some really cool, like I can see patterns here, right? Like because they're all, my first column is all being multiplied by the first column here. They all have 7s and 2s. And then my second column all has the 0s and the 6s. Why does this not have a 6? What did I do wrong? 1 times 0, 9 times 6. That's how you find mistakes. And then my last one should all have the 1s and 8s. And then if I look at my similar pattern across, 4, 5, 4, 5, 4, 5, 1, 9, 1, 9, 1, 9, negative 6, negative 3, negative 6, negative 3. Okay, so I went ahead and kind of checked it over and make sure I don't have any mistakes. So now I know that my answer matrix is going to be, because these are each going to work out to be one number. So I know I'm going to have a 3 by 3, but I have to do the work for that now. So 28 plus 10 is going to be 38. 0 plus 30 is just 30. 4 plus 40. And it is hard to do stuff like this. Maybe hard's not the right word, but I know that the more of these adding and multiplying that we have to do, the more likely it is to make a mistake. But taking that extra step like we did and trying to figure out where we might have went wrong and looking for patterns right away is going to help. We need a certain attention to detail in math, and I feel like that's part of what matrices do, is that attention to detail. All right, so now that I have worked out each of those mini math problems, I am just going to copy them down, and that's going to be my answer. Let's see, we have 38, 30, and 44 is my first row. 25, 54, 73, negative 48, negative 18, and negative 30. So there's my answer matrix. So this is, again, A times B is going to equal this. All right, now I want to look at BA. So for BA, I need to reverse the order of the matrices. And you might already be predicting what's going to happen when we multiply. And even though I'm using the same two matrices, this is going to work out completely different. Because now when I'm multiplying a row times a column, I have this row that has 3 elements in it, and I'm only multiplying it by 2 different columns. So what that means is when I multiply a row times a column now, I'm going to have the 7 times 4 plus, and then I'm going to multiply the middle things, then plus I'm going to multiply the last things. So we're going to end up with 3 groups of things being multiplied. 7 times 4 plus 0 times 1 plus 1 times negative 6. That's going to be one little answer thing when I'm done. And then I move on to my second column. So 7 times 5 plus 0 times 9 plus 1 times negative 3. And that's going to be, again, a second answer. There's really no reason to circle these other than I'm trying to get you to see that that's going to work out to be one number. It's going to group together. And now I move to my second row. So now I'm going to do my second row times each of those columns. So this answer matrix is only going to get 4 things in it. So my class brought up a really good point. They say, what if you go to multiply and we have 3 things in this row, but there's only 2 things in my column to match it up with? And the answer is, if we don't have equal numbers in this row, in this column, then I can't actually multiply. So I just can't do anything. And that will happen sometimes. And then as soon as I write this out, I do want to go back and check and make sure my patterns work again. This should be a plus sign. I almost made a mistake there. So 4s, 1s, 6s, negative 6s, 5s, 9s, negative 3s, 7, 7, 0, 0, 1, 1. So once you find those patterns with your multiplying, it's pretty easy to go through and check. So now it's the mini math problem time again. So 7 times 4, 0 times 1, 1 times negative 6. So I'm just going through and working each of these out. Let's see, this is going to be negative 34, negative 24. Let's see, what is that, 40? 30, 40. Okay, so 22, 32, negative 34, 40. So this is the part where we always like to stop and just kind of think about the ramifications of this. When I did A times B, I got a different answer than when I did B times A, which is not at all how math normally works that we're used to. We're used to working within the real number system where AB equals BA, but when we're looking at matrices, they are not equal. And so at the bottom here, we have some just properties of matrices, properties that they actually follow. So it's kind of a cool thing about matrices. You can tell how they just kind of break rules that we're used to. It's a very different way of thinking. And I think it's cool to kind of explore, like we've been saying, like a different number system that doesn't behave the same way. It stretches our brains a little bit. So multiplicative identity is where we're at, which is a really fancy name for something that you already understand. So multiplicative identity with real numbers. What this means is that if we have a times 1, it equals 1 times a, which equals a. So 1 is the multiplicative identity. So with matrices, we know that multiplication works differently. So with matrices, a times I is going to equal a. Actually, let's do it just like we did the other one. So let's say that equals I times a, which equals a. But instead of I just being a number, I is a whole matrix here. And so I is actually our identity matrix. And the identity matrix is right down here. It should look familiar. All these ones and zeros should look familiar. So with real numbers, 1 is our multiplicative identity. And with matrices, our identity matrix is going to be our multiplicative identity. So if I multiply something by this pattern of ones and zeros, then I get that same matrix back. And we're not going to prove this in class. There's not enough time to do all of that, but you absolutely could. You could pick any matrix. I could do a 2 by 2 or a 3 by 3 or a 4 by 4. And I think it's pretty easy. You can see how to, and so on and so forth, build this identity matrix. They're always square matrices, and they've got that diagonal of ones. Everything else is a 0. Okay, so next we are looking at multiplicative inverse. So identity is one thing, and now we're looking at inverse. So the way an inverse works for real numbers, because we're always trying to connect back to the real number system, that would be when we have a times 1 over a, it equals 1. So multiplicative inverse was always a fancy name for reciprocal when we were looking with real numbers. And you know what? I wanted to write down 1 over a times a. I wanted to show that we could multiply that either way. A different way of writing that instead of 1 over a would be a to the negative first power times a equals 1. So we know that 1 over a and a to the negative first power are equivalent. So with matrices, instead of multiplying to make 1, they're going to multiply to make our identity matrix. So a times the inverse of a, and we're using capital A's because we're looking at matrices, and you can see how a to the negative 1 power can kind of see why we would use the negative 1 power to denote an inverse matrix. So this is a matrix, and this is the inverse matrix. So the inverse to that matrix. And when I multiply those together in either order, I keep writing equal signs instead of times signs, I get the identity matrix. And this right here is going to be my multiplicative inverse or my inverse matrix. So now we're just going to prove that down below for number 2. So let's go to 2 and let's actually prove that. So in order to prove this, so if we're going to show that it is a multiplicative inverse, what that's doing is it's telling us to find AB, and that's going to equal BA, which is going to equal the identity matrix. So that's what we're going to do. And maybe find is the wrong word. Maybe I want to write show or multiply, but this is what we're doing. That's how we show that. So first I'm going to find AB. So AB would be this first matrix times the second one. And we know that multiplying them in different orders can give us different results. So the fact that they should both give us the identity matrix here is kind of cool. So we're doing row by column again. And they number of elements match up. There's 2 elements in this row. There's 2 in this column. So it's going to work. Negative 1 times 5 plus 3 times 2. And then we'll have negative 1 times 3 plus 3 times 1. This is always, I think, pretty cool when you multiply these out, because in order to get zeros, you're going to have tons of stuff cancel, and it's just pretty awesome. 2 times 3 plus negative 5 times 1. And then I just want to check again, 5s, 2s, 3s, 1s, negative 1, 3, negative 1, 3, 2, negative 5, 2, negative 5. Okay, so now I'm going to do my math. And I do, in fact, get that identity matrix. And then I want to multiply in the reverse order and show that it still works. All right, so let's try it again. Rows by columns, which again I can remember because matrices are row by column. 5 times negative 1 plus 3 times 2. All right, and then I'm just double checking my work. I always do that. It doesn't matter how many years I do math like this. I'm always checking for mistakes. So then we're going to go through and multiply again. All right. Once again, we got our identity matrix. And so that means that A and B are inverses. B is the multiplicative inverse of A. So we have shown what we meant to. So this is just really a lot of theory so far. So I am going to stop the notes here in just a second, but I want to kind of review what we're doing. So our goals for this part of the video were to be able to multiply matrices. And we did a couple different examples of those. And we talked about how you're using the rows in the first one by the columns in the second, and the number of elements need to match. So if I had one more row in this, if I had like a 5, 7, 8 here now, and there was 2 things in this row and 3 things in this column, I run out of elements, they don't match equally, and I would have to say that we can't do it. So that's something that's possible to happen. So this was just kind of basic. We're learning a pattern, and we're making sure we know how to multiply. AB does not necessarily equal BA, so we know we need to watch out for that. This was just a lot of real number theory stuff, but we are learning about the identity matrix. And so if I take something and I multiply by the identity matrix, I get that original matrix back. And we're going to be using the identity matrix for a lot. It's also worth noticing that this is what we came up with when we did Gauss-Jordan. It was that reduced row echelon form. So that should be familiar as well. And then we actually multiplied 2 matrices together. And I had to show that when I multiply A times B, it was the same thing as B times A. And either way, it equaled that identity matrix. And that meant we have inverses. So far in our notes, we haven't done anything really difficult, just a lot of kind of theory that we're going to use for later stuff. And we've mostly just practiced multiplying matrices. So this is going to be the end of our part 1 video.